Hello everyone, this is Siddhant Nanda and we are going to discuss a very beautiful topic of physics today. The topic is hydrostatics.
What is hydrostatic? Hydrostatic, it consists of two words. One is hydro. Hydro stands for fluids, and one is static. Static stands for something which is at rest. So what is hydrostatics? Hydrostatics is the branch of physics that deals with fluid at rest. Now here is a term called fluid. What is fluid? Fluid is something that can flow. Something that can flow is called a fluid. Something that can flow is called a fluid. Like matter has three states. One is solid, liquid, and gas. But out of this, solid cannot flow, but liquid and gas can flow. Since these two can flow, so these two are called as fluids. Right? You got this? Now let us go into the properties of liquid. Properties of liquid. What are the properties of liquid? First property, it has no fixed shape. Its shape is not fixed. Then what will be the shape of liquid? The container where the liquid is kept. Like let us consider a bottle, and the bottle has a liquid. Now the shape of liquid is like this bottle. But same liquid, when it is kept in a glass, the liquid occupy the space of glass, hence its shape is like the glass. So liquid has a shape equal to that of its container or that of the container where it is kept. It has a fixed volume. That means if this bottle has 200 ml of Coca-Cola and we put that Coca-Cola in this glass of, then the glass of Coca-Cola will also be of 200 ml. Volume will not change transferring the liquid from one container to another. That means what? Volume of the liquid is fixed. And third, it is incompressible. What is incompressible? Incompressible means its volume will not change appreciably with apply of pressure. Initially, let's say its volume was V1, then after applying pressure, its volume will not change. It will remain V1 as well. Before applying pressure and after applying pressure, volume remains same, nearly same. Not always exactly same, but nearly same. Okay. 4. Its density is independent of pressure applied. These are the properties of liquid. Now, what are the properties of gas? Though liquid have some other properties also, the properties we are going to discuss in this point of chapter, we have these four properties. Okay, some more are also there, but we will discuss it later on. Likewise, properties of gas. In context to this, gas also don't have a shape, but liquid has a fixed volume. Gas even don't have that. No fixed volume. Like liquids are incompressible, gases are compressible. What is incompressible and compressible? Let's see. If you observe the molecules of liquid and gas, in case of gas, the molecules are far away from one another. That means they have large intermolecular distance. When pressure is applied to them, this intermolecular distance, it is changed. That means since here is a space available, since here is a space, the space is available for these molecules to come closer, they comes closer after applying pressure. But in case of liquids, no such space are available. So even if pressure is applied, these molecules cannot come closer than this degree of closeness. That's why the intermolecular distance is not changed in liquid in an appreciable amount, rather that is very vast in case of gas. So when pressure is applied, they are compressed, they comes closer. This property is called compressibility. So what is compressibility? Compressibility is the property of a substance by virtue of which its molecules come closer than their original distances among the molecules when pressure is applied to them. Right? That's why their density before applying pressure and after applying pressure are different. So you can say its density is dependent on pressure. So these are the properties of gases. Now, one topic we are discussing more over here is about density. What is a density then? Density of a substance is the ratio of its mass and its volume. That means if there is a substance, its mass is m and its volume is v, then density rho, this is the symbol of density, rho. This rho is equals to mass by volume. What will be its dimensions? Dimensions will be that of mass and that of volume, that is m1 L minus 3 T naught. What will be its units? In SI it is kg per meter cube. In CGS, it is gram per centimeter cube. Okay. Let us go into a question. It is asking, what is the density of a gas of 12 gram occupying a space of 120 cm cube. Mass is given 12 gram, volume is given 120 cm cube. What is density? Mass by volume. That is 12 by 120. Result is 1 by 10 gram per cm cube, or 0.1 gram per cm cube. Likewise, let us go for another question. The question is, if gas at room temperature has a density of 1.29 kg per meter cube placed in a room of 4 meter cross 3 meter cross 3 meter, then what will be its mass and weight? What will be its mass and weight? Now, here volume is given 1.29 kg per meter cube. Volume is given, that is this one, 36 meter cube. It is asking to find mass. Now we had a formula, rho is equals to mass by volume. This implies mass is equals to rho into volume. What is rho? 1.29. What is V? 36. This much kg. Now we got mass. Tell me, what is the weight then? Weight is nothing but mass into acceleration due to gravity. That is 1.29 into 36 into acceleration due to gravity is 9.8. Result is this much kgf, or this much Newton. Can you differentiate why mass has a unit of kg and weight has a unit of Newton? Why? Because mass and weight are not the same. Weight is a force. Mass is not a force. Clear? Another term we are going to discuss is weight density. Weight density is denoted by capital D. What is a weight density? Weight density of a substance is the ratio of weight of that substance to its volume. That means if the substance has a weight of W and its volume is V, then D is equals to weight by volume. What will be the dimension of D? And what would be the unit of D? Unit of D will be like, since it's a weight, it is Newton, and its volume, since meter cube. So in SI units, it will be Newton per meter cube, and in CGS, it will be dyne per cm cube. Why do I left this dimension or dimensional formula to find? Please watch the video clearly and send me the dimensional formula of D in the comment section. I'll be waiting for your comments. Now, there is a relation between mass density and weight density. Like D is equals to weight by volume. As we know, weight is nothing but mass into acceleration due to gravity. That's why it is mass into acceleration due to gravity by volume. Mass into acceleration due to gravity by volume. So, D is equals to mass by volume into acceleration due to gravity. This mass by volume is nothing but mass density rho, as we have studied. That's why this is a relation between weight density and mass density. Let's see, have a question. The question is, a substance has mass density of 1.6 kg per meter cube. What is its weight density? Mass density is given, that is 1.6 kg per meter cube, and it is asking to find the weight density. We have a formula. Weight density is equals to mass density into acceleration due to gravity. So D is equals to 1.6 kg per meter cube into 9.8 meter per second square. So my formula is, my value is 1.6 into 9.8, say kg meter square inverse second square inverse, or Newton per meter cube. Either this or this. Okay. Density of water. Water is a very interesting liquid. Its density decreases with increase in temperature. That means on melting, its density increases. That is, let us consider a ice cube which was at 0 degree centigrade. We started it melting and it comes to 4 degree centigrade. Now during this process, its density increases. After 4 degree centigrade, when it is further heated, its density decreases. Okay, and then this way 0 to 4 degree centigrade, here too density 4 towards 0 degree centigrade, on losing heat its density decreases. So where it has a maximum density, the density of water is maximum at 4 degree centigrade. Here you will get maximum density. Okay, so at 4 degree centigrade, the density of water is of 1 gram per cm cube, or 10 to the power 3 kg per meter cube. This value is a standard and fixed value. Now, there is a term called relative density. What is relative density? Let us consider a substance. At T degree centigrade, its density is rho 1 or rho s, density of the substance. Then relative density rho r is nothing but, this is denoted by rho r, then rho r is nothing but the ratio of density of substance at T degree centigrade to density of water at 4 degree centigrade. So you can write the relative density of a substance at T degree centigrade is the ratio of density of substance at T degree centigrade to density of water at 4 degree centigrade. Okay, this is what is also called as specific gravity.
Thanks for watching the video. I hope the video will be helpful for you. If you have any doubts, any queries, please write in the comment section. I'll try to solve that out and try to come with a video with your queries. Till then,